Hey, CP Math 1, this is Mr. Roberts at Shasta High School. And as we discussed today in class, it turns out all three of these systems are good candidates for the method that we call elimination. Remember, the goal of elimination is to get one of our variables to cancel when we take equal things and we add equal things to both sides of it. Now, I want to start with this middle one because I think it's kind of the easiest to see. If I were to combine equal things with equal things, I get equal things, right? So if I look, this first statement tells me that 6a minus b is equal to 3. So these are equal things. The bottom one tells me that b plus 4a is equal to 17. So 17 is equivalent to b plus 4a. So if I take equal things and I add equal things, I get equal things. And I know I say that and just like that sounds mean, right? To say, let me just write this down. Hey, 5 is equal to 5. Those are equal things. And if I add to both sides of this things that are equal, like for example, 2 is equal to 2. If I take these equal things and I add these equal things to both sides of that, I get the following. I get 7 is equal to 7. And as an abstraction, that's what's happening here, right? I'm taking some equal things from the top equation, and I'm adding some equal things from the bottom equation. I'm getting equal things. Over here, when I add these two things, right, 3 and 17, I get the number 20. And over on the right-hand side, when I add these, right, 6a minus b plus a b plus 4a, right, 6a minus b plus a b plus 4a. Notice I've got a negative b and a positive b, so those combine to become 0. So b just got eliminated, and I'm left with 10a. So now this equation is pretty easy for us to deal with. I'm just going to divide both sides by 10, and I get that a is the number 2. Now that we know a is 2, right, our goal is to figure out both a and b. So what I'm going to do is set it up so I can figure out what b is. I'm going to use this second equation again to do that because now in the second equation I know what a is. So I'm going to write the following, right? I'm just rewriting the second equation. The second equation begins with b, so I write b. Then it has a plus, I write a plus. It has a 4, I write a 4. And then it has a, but instead of a, I'm going to write down what I found a to be. So I'm going to write down the number 2. So notice what I've just written. I've written b plus 4a, which is what I had, b plus 4a. And that equals the number 17. So in other words, b plus 8 is 17. And if I take away 8 from both sides, I get that b is the number 9. So my solution here is that I've got that b is 9, and I've got that a is the number 2. Now, it's definitely worth it to check a solution. So I'm going to look at the top equation, and I'm going to look at my values that I think a and b are. This says 6a. Well, 6 times 2 is 12. So this top equation becomes 12 minus what b is, which is 9. And 12 minus 9 is the number 3, which is what the top equation tells me it's supposed to be, right? It's supposed to be 3. So I'll put a little check mark here, meaning that the top equation worked. I'm going to do the same thing with the bottom equation. The bottom equation says take b, okay, which is 9, okay. And then to that, I'm going to add 4 times a, which is 8. And if I add 9 plus 8, I do get 17. So that also checks. So what I have here is I have the values of a and b, 2 and 9, that make both of those equations true. So that's why this is the solution, because it satisfies both of the equations. So let's take a look at the other system that I had, the first system. On the first one, we're very close, right, to having this set up so that things will eliminate. However, you'll notice that I have both a positive 2n and a positive 2n in each of them. But I want one of my variables to be the opposite as the one in the other equation. So in order to achieve this, I'm just going to go ahead and take this top equation and I'm going to multiply it through. I'm going to multiply both sides, every single term on both sides, by the number -1. So I'm just going to multiply everything by -1. And to keep this a little cleaner, I'm going to go ahead and write this equation right here. So I've got negative 1 times 5m, which is going to be a negative 5m. And then I'm going to have negative 1 times 2n, which is going to be a negative 2n. And then negative 1 times negative 10, which is going to be positive 10 on the other side. So this is my top equation, just rewritten so each of the terms was multiplied by negative 1. It's still an equivalent equation because if I have equal things and I multiply both sides by an equal value, I get equal things. Now, I'm going to rewrite this second equation right below there just so visually, I like to have them together nice and clean. So I'm going to go ahead and write 3m. And then plus 2n, and that's going to equal a negative 2. So now I've got n being exact opposites, right? I've got a negative 2n and a positive 2n. So when I combine those, I get 0. In other words, n's going to get eliminated when I take these equal things and I add these equal things to it. On the right-hand side, I'm going to get the number 8. Where'd that come from? 10 plus negative 2. On the left-hand side, we're going to have the negative 2n and the positive 2n eliminate, and I'm going to have a negative 5m and a positive 3m, which is going to be negative 2n. And then I'm going to just divide both sides by negative 2n. So when I get over here, when I divide by negative 2, and when I divide this by negative 2, I get negative 4. So n apparently is negative 4. Can't really check it yet until I figure out what m is also. So I need to figure out what m is. It doesn't matter if I use the top equation or the bottom equation to find m. I think I'm just going to arbitrarily go ahead and pick I'll pick the bottom equation. So for the bottom equation, I'm going to write 3 times m plus, now I found that this is ridiculous here. I can see this error. My n's eliminated, right? No, my n's eliminated. So this is supposed to be a negative 5m and a positive 3m. So this is supposed to be m. So what I found was m was negative 4 because a negative 5m plus a 3m becomes negative 2m. It doesn't become n. The n's got eliminated. So I know now that m is negative 4. So I'm going to go ahead and write 3 times m, which is negative 4. 3 times m, and then plus 2 times n, and that's going to equal negative 2. So I just rewrote the bottom equation. When I got to m, I placed what I believe m to be, negative 4. So I've got 3 times m plus 2n is negative 2. This is going to be a negative 12 plus 2n is negative 2. If I add 12 to both sides, I get that twice n is the number 10. And if I divide, I'm way out of my, and if I divide both sides now by 2, I get that n is the number 5. So I believe, right, I believe that m is negative 4, and I believe that n is 5. But I should take a moment and try to check that, and I'm going to just check it off in the margin here a little bit. So this thing says take 5 times m. Okay, m was negative 4, so that's going to be a negative 20. 5 times m, and then plus 2 times n. N was 5, so that's going to be plus 10. And yeah, if I combine negative 20 and 10, I get negative 10, which is what it's supposed to be, according to this first equation. And if I check the bottom equation, it says 3 times m. Remember, m is negative 4, so 3 times that would be negative 12. And then plus 2 times n, which would be 10. And negative 12 plus, this is 10, does equal negative 2, which is what it's supposed to be. It checks. So I'm confident in both of my answers. I've got m is negative 4 and n is 5. And for the second problem, we had b was 9 and a was 2. For our last problem, right, in some ways we're closer because you can see I've got I've got negative y's and I've got positive y's, except they're not exactly opposites. They're certainly opposite in signs. One's positive and one's negative. But I need this number to be the number 4, right, for this to truly be opposites. So what I'm going to do is I'm going to take the second equation and I'm going to just multiply it through by a positive 2. And if I multiply it through by a positive 2, this 2 times negative 2y is going to become a negative 4y. So I'm going to rewrite, I don't really have enough room here, so I'm going to rewrite the top equation. 7x plus 4y is 17. And now I'm going to go ahead and multiply the second equation through by positive 2, and I get the following result. It's going to become 6x minus 4y equals negative 30. Perfect. That got multiplied, negative, or 3x got multiplied by 2, negative 2y got multiplied by 2, and negative 15 got multiplied by 2. Now I have my equal things. I'm going to add equal things to both sides of that to get equal things. When I combine my 17 and negative 30, I get a negative 13. Ugh, yeah. 17, yes, I get a negative 13. My 4y and my negative 4y combine to form 0, and 7x and 6x is 13x. So if I divide both sides of this by 13, I get that x is the number negative 1. And now that I know what x is, I just need to use one of these equations. It doesn't matter which one to find y. I like the top one because the coefficient of y is positive. So I'm just going to go ahead and write 7 times what x is, 7 times what x is, which was negative 1, plus it says 4 times y is equal to 17. Okay, so negative 7 plus 4y is 17. If I add 7 to both sides, I get that 4y is 28. And if I divide both sides by 4, that's 14 is half of 28 divided by 4. Am I really picking up a calculator right now? Oh, that's my problem. 17 and 17. 7. No. What am I doing? I'm adding 17. 17 plus 7 is 28, right, Roberts? 17 plus 7. No, that's my problem. If I, when I add 7 to both sides of this, I got a big boo-boo here. 17 plus 7 is 24. And you can see the mistake I've made. So this should be the number 24. I'll rewrite this. 4y is 24. My goodness. Now 24 divided by 4 gives me that y is 6. Y is 6. So my solution should be the ordered pair where x is negative 1 and y is 6. So again, checking this is a super good idea. So if I was to plug in x here, I would have negative 7 plus 6 times 4. 6 times 4 times 6 is 24. And if I add negative 7 and 24, I do get 7. Although I'm shaken by my incompetence, so it's just an arithmetic deficiency. 24 plus negative 7, yeah, is 17. Thank you. So that one checked. And then the bottom one says 3 times x, so that's going to be a negative 3. And then y is 6, so negative 3 minus 6 times minus 12. And negative 3 and negative 12 together are negative 15, which is what it should be, negative 15. So all of these do check, right? So my last answer there is negative 1, negative 6. So solving systems of equations using the elimination method. We've also already considered the equal values method, and we've considered the substitution method. This is the last technique we'll practice on. So we are done here for now. Thanks for watching.